Hello. In this video, we're going to look at some consequences of the remainder theorem. First of all, let's look at just a general statement here. A degree n polynomial has at most n zeros. Okay, so a degree n polynomial has at most n zeros. This is important to keep in mind. Next, given a zero k, we want to use synthetic division to find all remaining zeros. Now, what this is telling us is it's a little bit different from the videos that we just saw. We have a function f of x, and we're given a k value that is a zero. Now, that's telling me that this should be the fact that f of 3 is equal to 0. But we're going to prove that fact with synthetic division. Now, synthetic division means we take that k value of 3 and do upside down division, and then write down all coefficients. We have every term, so we don't need to include any zeros. So we have a 1, -6, -1, and 30. Bring down the 1, multiply, add, multiply, add, multiply, and add. Notice that we just proved that k equals 3 is, in fact, a 0. That's fantastic. We love that. But here's the thing. If we were to actually do the division, what we really just did is we just did, x cubed minus 6x squared minus x plus 30 all over x minus 3 is equal to x squared minus 3x minus 10. That's what this is telling us here. Okay, now with that information, that's telling me that we can actually factor this function. So this function can be factored as the following. We could factor it as x minus 3 because a 3 tells us a factor of x minus 3. And these coefficients tell me x squared minus 3x minus 10. And if we set the entire thing equal to 0 and solve, notice that x minus 3 gives us x equals 3. That's the reason 3 is a k value here. And then here, that's not really an underscore, that's a minus there. Oops. There we go. Right here, x squared minus 3x minus 10, I can set that equal to 0 and solve. So I can do that either as a quadratic equation over here, or later on, we're going to look at finding zeros in another way. But let's just look at x squared minus 3x minus 10 and set it equal to 0. Notice that that can be factored. It's actually very easy to factor as two sets of parentheses. We have an x here and an x here. Negative here means that the one's positive and one's negative. Ask yourself what multiplies to 10 and has a difference of 3. Well, that'd be 2 and 5. And notice that the 3 is negative, so the 5 has to be negative and the 2 has to be positive. And then set each one equal to 0 and solve. Fantastic. And we just completed what we were asked to do. I will say, however, you don't have to do it this way. You can use the calculator to look and see where the function is crossing the x-axis again and say, oh, look, I can continue here and just keep going. Notice I would have a -2 here for the 0 of -2. Bring down the 1, multiply, add, multiply, and add. Notice that we get a 0 here. Fantastic. And then here we have one more. We can go with synthetic division again, using the 5, bring down the 1, multiply, and add. And notice that these are the zeros. This is just the leading coefficient. That's all it is. So let's be very clear about the fact that this is just a leading coefficient. Okay, good deal. So just to make sure that we are clear about what our answer here is, the remaining zeros are the following. -2 and 5. That is our answer. Now, if it asked for all zeros, not just the remaining zeros, all zeros of this function are -2, 3, and 5. And it just depends on what the question's asking for. If it asks for the remaining zeros, just give these 2. But if it asks for all zeros of the polynomial function, make sure that you list all of them. Now notice that this is degree 3, so it has at most 3 zeros. There they are. Alrighty. Well, I'm going to go ahead and leave this video here, and I will see you in the next one. Have fun.